Hello, and welcome to the next video in my series on basic statistics, and for this video, finite mathematics. The topic in this video is taught in both stats courses and finite math courses, so you may be watching this video in a stats playlist or in a finite math playlist, but rest assured it does apply to both. Now just a reminder, these videos are geared towards individuals who are relatively new to stats or finite math for that matter, so I'll just be going over the very basics. The problem in the video will be worked step by step, very slowly, very deliberately, and I will explain every single thing we do so you can fully understand not only the mechanics of the problem, but why things are going on. And finally, if you're watching this video because you're having problems in a course, I want you to stay positive and keep your head up. If you're watching this video, it means you've probably come pretty far in your education up to this point. So you might just be having this little hump to get over. So with hard work, some commitment, and study and things of that nature, you can get through it. I have faith in you, and so should you. So all that being said, let's go ahead and get started. Now in this video, I'll be continuing our discussion of basic counting principles. In previous videos, I've discussed the differences between permutations and combinations, and since then, I've gone into more depth about combinations specifically. I'm going to do some more on permutations here in a bit. But this video and my last two videos really walk you through standard problems that you are going to see in stats or finite math. You know, every topic kind of has a standard type or basic type of problems that are used in chapter examples and in the back and things like that. So these questions represent those. Now I call this question Dogs of the Dow. So what is the Dogs of the Dow? It sounds kind of goofy, and in a way it does, but actually it actually has a meaning. The Dogs of the Dow is a list of stocks on the stock market. And these stocks pay the highest dividend yield. And we'll talk about that just briefly in a minute. You don't have to know anything about finance or anything to understand this problem. This is just the data example I pulled. So the dividend as a percentage of stock price. And remember, a dividend is a cash payment to shareholders. So if you're an investor yourself, you know that probably several of your stocks pay you a quarterly dividend, hopefully at this point. And then you can either take that dividend as dividend income, or you can reinvest it to buy fractions of more shares of whatever stock that is. So a dividend is fairly commonly known. Now, the Dogs of the Dow, it's a list of 10 stocks. And here in this chart, you can actually see them. And this is as of December 31st, 2011. So in the first column, you have the symbol. In the second column, the actual name of the company. And I would imagine you've probably heard of all, if not most, of this list. So everyone's probably heard of Verizon, General Electric, Intel, and things like that. The third column is the stock price. We're not going to be using that in this example, but that's just the price of the stock. And then the last column is the dividend yield. And again, that's a sort of a percentage of the stock price that's paid out as a dividend over the course of the year. So again, you don't have to know the basics of finance to understand what we're doing in this video, but that's sort of the data we are using. And if you are someone that relies on dividends for your income, like a lot of retirees, then the yield is quite important. Okay, so this is just our data set. Now, as a retired investor, we're going to assume you're a retired investor, you rely on dividend income as part of your overall income stream. So like I said, a lot of retired persons buy stocks that pay dividends. And then on a quarterly basis, they will get a dividend check. It's called dividend income. And they can use that for whatever they want, just like any other income. And then younger persons may take that dividend not as a cash payment to them, but they use it to buy more stock in whatever company. So there are the two common uses for it. but you're a retired investor and you take the dividend as income. So your investment strategy calls for developing a group of 5 stocks from the Dogs of the Dow list. So you're going to develop a portfolio of 5 stocks from this list. Now there are certain stocks you feel you may definitely want to have in this 5 stock portfolio. Maybe because you like them, or they're familiar to you, or you use their products so you feel close to them. But you definitely want to have GE, or General Electric, and P&G, Procter & Gamble, in this portfolio. So you're definitely considering that. Now you're also considering a scenario where at least 4 stocks in your 5 stock portfolio have a dividend yield of at least 3.5% or more. So 4 out of the 5 stocks in your portfolio must have a dividend yield of 3.5% or more. So here are our questions. How many different 5 stock portfolios are possible out of the 10 we have to choose from? Number 2, how many different stock portfolios contain GE, General Electric, and P&G, Procter & Gamble, but do not have Intel nor Kraft in them? So you're going to develop portfolios that have GE and P&G, but do not have Intel or Kraft. And we're going to talk about how to solve that. And finally, how many different portfolios contain at least 4 stocks with yields above 3.5%? So we're going to have some portfolios that have 4 stocks that meet that criteria, and portfolios that have all 5 stocks that meet that criteria, at least 4 stocks. Okay, so let's tackle our first question. How many different 5 stock portfolios are possible? And this is actually very simple. We've done this several times in the past. So actually think about creating a folder full of 5 stocks. Now for this answer, we're just going to figure out how many ways we can choose a group of 5 different stocks out of the total of 10. So it's 10, choose 5. And we write it in this manner. In finite math, we write it like this usually. You might see a little bit differently in a stats book, but it means the same thing. But 10, choose 5 is 252. So therefore, there are 252 different 5 stock portfolios that could be made from the Dogs of the Dow list. So a group of 5 stocks, 5 different stocks, there are 252 unique groups of 5. So let's go ahead and take a very quick look at that on film. Okay, so let's go ahead and do a film of the first part of our problem, which is actually very simple. So here I've sort of made playing cards of the 10 stocks that are in the Dogs of the Dow that we're going to be choosing from for the problem. And you can see we have everything from DuPont, Merck, Johnson & Johnson, AT&T, Kraft, and then GE, Intel, Procter & Gamble, Verizon, and Pfizer. So the first part of our problem simply asked, how many potential or possible portfolios can we have consisting of 5 stocks out of these 10? So this is very similar to just like a deck of playing cards. I actually made sort of playing card like props here. So if I were to shuffle these up, kind of like, playing cards, I shuffle them up. All right, and I deal myself 5, 2, 3, 4, and 5. All right, so that's one possible portfolio of 5 stocks out of the total of 10. So Verizon, AT&T, Pfizer, Johnson & Johnson, and DuPont. So if I go ahead and pick those up, I shuffle them again real good, best I can. It's hard to shuffle index cards. Okay, so I did shuffle them, and I'll cut them again. We'll do 5 this time. So GE, Procter & Gamble, Kraft, Intel, and Pfizer. So that's a different group of 5.
So remember, we found out in our problem that there are 252 unique groups of 5 stocks that we could put in a portfolio. And remember that this portfolio is the same as this portfolio. Doesn't matter. It's the same 5 group of stocks. So there are actually 250 unique groups of 5 stocks out of our 10 dogs of the Dow stocks.
Okay, on to our next question. How many different stock portfolios contain GE and P&G, but do not have Intel nor Kraft? Well, I always tell the students I work with to make some sort of drawing or chart or diagram, something like that, because it really can help you visualize. We are increasingly a visualization culture. So I tell my students to draw pictures, whatever they need to do to understand the problem. So for this one, I went ahead and made a little diagram here that actually contains the information in our prompt. Now we know we have to have, or we want to have, GE and P&G. So if you look here, I have colored those green, because those are good. Green is good, kind of like a stoplight. So we have those two as green. Now we know we do not want to have Intel nor Kraft. So I've colored those two red. So you can see Intel there in the center and Kraft at the lower right. Now the others, we have really yet to decide what we're going to do with them, but we can use them. They're definitely allowed to be in our portfolio. So I went ahead and colored those sort of a yellow or orange color. So this is just a visual representation of the information we have in our prompt there at the top. So we must have P&G and GE. Those two are a fixed group or a unit. So really here you cease thinking about those two as two separate stocks. We're thinking them as a group. P&G and GE we have to have. So now we have 3 more selections to make, because those account for 2 of our 5, so we still have 3 more to choose. Now, up till now we have 8 to choose from, because P&G are 2, that takes 2 out of the 10, and we're left with 8. But, of course, we do not want Intel or Kraft. So instead of 8 remaining stocks to choose our final 3, we only have 6 to choose from. So the red ones are no longer, up for selection. Only the orange, yellow ones are. So how do we solve this problem? Well, again, we think of P&G and G&E as a group. Now that group can be matched with any 3 of the remaining 6 that we can put on our portfolio. So this is the group of P&G times 6 choose 3. And that's just taking our P&G GE unit and matching it with 3 of the orange stocks there that we can choose from. So we treat the unit as 1 times 6 choose 3, and that equals 1 times 20, which is, of course, 20. So this complicated set of conditions we have at the top, it contains GE and P&G, but not Intel nor Kraft. A lot of students I work with will see that and freak out. They're like, oh my gosh, I don't know how to solve that. But if you go ahead and draw a diagram, it makes it a whole lot easier. If you walk through it systematically, of course, it's easier to solve. And in the case of this problem, it's actually quite simple once you get down to the bare knuckles of it. So there are 20 different portfolios that have GE and P&G, but do not have Intel nor Kraft. Let's go ahead and take a look at that on film real quick.
Okay, let's go ahead and take a look at the second part of our problem. Now remember, in this part, we're trying to create specific types of portfolios, and we set some conditions on those. We decided that we do want Procter & Gamble and GE in our portfolio. So we have P&G and General Electric over here off to the side. Now that leaves us with 8 other stocks to choose from to fill out the other 3, because remember a portfolio is 5 stocks. So these 2 are already given, they're built in. But now we have 8 to fill the other 3 spots in our portfolio. But remember, we also set a condition that says we really do not want Intel nor Kraft. So maybe those stocks aren't doing well right now, or whatever. So we're going to take out Intel and Kraft. So now, to fill out the next 3 stocks in our portfolio, we don't have 8 to choose from, we only have 6. Now remember what I said in the video, the PowerPoint part, that we have to treat GE and P&G as like a group. So it's kind of like its own pair or unit or whatever else. So this is sort of one unit. Now we have to come up with portfolios that match this unit with any 3 of these 6. So this is our 1 unit, and this right here are our 6 choose 3. So I'm not going to go through all those, but just think we could have GE and P&G as a group over here, and we could do those top 3 like that. Or we could do the bottom 3. Or we could do those 3. Or those 3. So this unit, then we have over here 6 choose 3, which is 20. So 1 times 6 choose 3, which is 20, will give us 20 different portfolios that involve definitely having General Electric and P&G, not Intel or Kraft, so these are no good. And then the next 3 can be any of these 6. I just went through some of the combinations for you. I could sit here and go through all 20, but that would be really boring. So you can just imagine any 3 of these. So that gives us 20 possible portfolios.
Okay, and finally, how many different portfolios contain at least 4 stocks with yields that are equal to or greater than 3.5%? So here's our chart again, and I went ahead and changed the color of the stocks that meet that criteria to green. So the green stocks all have yields greater than or equal to 3.5. So let's think about our outcomes. Remember, it says at least 4 stocks. So outcome 1 would be a portfolio with 4 stocks that are greater than or equal to 3.5% dividend yield. Our second outcome would be a portfolio with all 5 stocks that are greater than or equal to 3.5% dividend yield. So when we have at least 4 stocks in our prompt there at the top, we have to consider 2 outcomes. 4 stocks with that yield and 5 stocks with that yield. So let's go ahead and take a look at those. Now there are 6 stocks with a dividend yield of greater than or equal to 3.5%. So again, I'm going ahead and color coded these so you can see exactly what they are. So all the stocks there in the green, Merck and AT&T, Verizon, etc., they all have yields that meet our criteria. Now how do we solve this problem? So we need a portfolio with 4 stocks that have dividend yields greater than or equal to 3.5%. So this is actually quite straightforward. We need to select 4 of those 6 stocks, so that's 6 choose 4. We still have 1 more stock to pick, and there are 4 of those, so that's just 4 choose 1. So 6 choose 4 times 4 choose 1 is 15 times 4, or 60. So that's one outcome. Now let's consider the other one. A portfolio with all 5 stocks having a dividend yield greater than or equal to 3.5%. And this is really easy. It's just 6 choose 5. All 5 of our stocks have to have this yield. there are only 6 of them that do so. So we're choosing 5 from a total of 6. So 6 choose 5 is 6. Now remember, this is part of our questions. We can have 4 or 5. So those are both valid answers here. So we just have to add those together. So remember in our previous slide, outcome 1, we had 60 possibilities, 60 portfolios. In this example, we have 6. So we add those together, 60 plus 6, and we have a total of 66 portfolios. Okay? So, in this case, there are 66 portfolios that have at least 4 stocks with a dividend yield that's greater than or equal to 3.5%. Let's go ahead and take a look at this problem on video. Then we'll come back, do a very quick probability example, and then we're done.
Okay, let's take a look at the final part of our problem. Now remember in part 3, we were tasked with finding the number of portfolios that have at least 4 stocks with dividend yields that are greater than or equal to 3.5%. So we can have 4 stocks in our portfolio that have that yield, or all 5 must have that yield. So let's look at the first option, the first outcome first. So I'm going to go ahead and place my stocks in 2 groups. They either have a yield of 3.5% or more, or they don't. So over here we have Pfizer, that does have a yield of 3.7, so that's good. DuPont, 3.58%. AT&T, definitely 5.82. Intel does not. It's only 3.46%. GE does at 3.8%. Merck does at 4.46%. Johnson & Johnson does not. It's only 3.48. Verizon does at 4.99. P&G does not. It's at 3.15. And then Kraft does not. It's at 3.10%. So everything on this side has a yield of 3.5% or higher, and then the stocks on this side do not. So what's the first part of our solution here? Well, we got to have 4 stocks that have yields on this side, and then therefore 1 that does not. So any 4 of these 6, and any 1 of these 4. So that's where we come up with our 6 choose 4, and then 4 choose 1. So that'll give us 4 stocks that have the yields of 3.5% or higher, and then 1 that does not. So 6 choose 4 times 4 choose 1. And again, we can make any 4 over here. Let's say these 4 could go with that 1. And that would be our 5 stocks. Of course, I could put these back. And I could do it differently. I could say these 4 and that one. So again, all we're doing is 6 choose 4 over here, and then 4 choose 1 over here. Now, the second part of this is, what if we have, how many portfolios can we have that have yields that are all greater than 3.5%? So all 5 stocks. Well, guess what happens to these? Ain't gonna work. So that's that. Now all we're dealing with are the 6 stocks that have the yield of 3.5% or higher. So choosing 5 of these is very simple. It's just 6 choose 5. And of course, there are only 6 ways to do that. I'll actually show you because it's so easy. We can have those 5, those 5, those 5, those 5, those 5, or those 5. So 6 choose 5 is 6. Now remember, when we had our previous example, or part of this problem, put those back. we had 6 choose 4 times 4 choose 1. And that comes out to 60. Okay? 6 choose 4 times 4 choose 1 is 60. And then 6 choose 5 here is 6. So 60 plus 6 is 66. So there are 66 portfolios out of the 252 that will have 4 or more stocks with dividend yields of 3.5% or higher.
Okay, so we're just about done. I just want to throw this little extension of the problem out there because later on I'll be talking more about probability specifically. But here's our question. If we randomly select 5 stocks for our portfolio, what is the chance our portfolio has at least 4 stocks with a dividend yield of at least 3.5%? So this is actually the problem, the last problem in our series of 3. So what does this come out to be? This is actually much simpler than it looks. I'm just kind of putting the text in the problem. So the probability of at least 4 stocks with this yield equals the number of portfolios that have that criteria, so 4 or 5 stocks greater than or equal to 3.5% yield, divided by the total possible portfolios, which was actually the first question we did in this series. So that's just 66 divided by our total number of portfolios, which was 252. So we do that division, and that ends up being 0.262, or about 26.2%. So if we were to randomly select 5 stocks, put the 10 stocks in a bowl and mix them up, and we select 5, the probability that those 5 that we choose out of the bowl have 4 or more stocks with this yield is 26.2% probability. Okay, so that wraps up our video on combinations, and in this case, what makes this problem a little bit different is we set some different criteria in it. We said we have to have these 2 stocks, but we can't have those 2 stocks, and we kind of have to fill in the middle part. And that's a very common type of problem that you'll come across in finite math and stats when doing counting type problems. Now again, if you're having problems in a course, I want you to stay positive and keep your head up. Hopefully this video helped, and other screencaster videos will help on YouTube or wherever else you watch them. You've come this far, so I know with a little bit of work and patience that you can get through whatever problems you're having in class. Again, I have faith in you, and so should you. So, all that being said, thank you very much for watching, and I do look forward to seeing you again next time.